Hey everyone, welcome to MP201 for September 14th, 2013. Today is our second class, and today we're going to be going over spindle cutting and spindle modes. We're going to be talking about cutting on the left spindle, cutting on the right spindle, how do we keep those separate, and we'll be talking a little bit about lathe versus milling mode as well. As part of that, we're also going to go through the process of creating some toolpaths and talk about which toolpaths to use and why. Talk about why we want to use certain toolpaths and not others. One of the things that's kind of interesting about lathe is that the representation you see of your stock on the screen is directly affected by the placement of this insertion point arrow. So you'll notice as I take this arrow and I drop it into the chuck events for the pick-off cutoff, here's the cutoff pick-off sequence, you'll see it affecting where that position of the stock and the spindles are with their chucks on the screen. So just something to note that can get a little confusing is, okay, if I'm going back in to add operations, how do I do that? Something that I think is important to note is that if you do need to go back in here and change your operations, a lot of the times you can get screwed up. You know, you'll be going back, you'll try to add something, and it'll just, all your tools will start crashing into stuff because it doesn't know about the clearance on your chucks, and you can have all these problems. So what I tend to do, if I need to go in and I need to modify my first program here, I will typically go in and delete both pieces of stock. What's going to happen is it's going to make all of your operations go dirty, but then you can easily modify your main spindle program and then generate your pick-off cutoff, and all you'll do is select all of the dirty pick-off cutoff operations and hit regenerate, and then do your sub-spindle work. The thing that happens is that this pick-off cutoff operation comes over here and it grabs a piece of stock. And so what'll happen is if you go back in here to modify this and it tries to regenerate the sequence, you're already going to have stock over here, and it just comes over here and you'll get collisions, or it'll say there's already stock in the second spindle, we can't continue. So just a word of warning. So this is a part that Josh programmed for his machine with his old post, and we're redoing that post during this class. And what we're going to do is actually just post it out and look at some of the code to familiarize ourselves with it. So right off the bat, as we start to look at this, we've got some lathe operations here. You notice lathe face, lathe rough, lathe finish, lathe drill, lathe rough, and then we go into some actual milling operations. So here we're getting some reference returns. In other words, we're sending different axes home into different positions. We're doing our tool change, and in lathe, when we do a tool change, it calls up both the tool number and the offset number that gets applied if we're doing cutter compensation. So just be aware of that. We've got our work offset, and then we've got G18, G99, and I'm pretty sure the G18 is our plain code. Hey Josh, can you comment on the G99, what that does for your mooring? Let me see if I can unmute you here. Hey, Josh, you there? Mic not working. Oh, that's okay. That's okay. So is G99 like a reference return for that lathe? Suppose I can go look it up in your post. Just want to make sure that we're all familiar with what we're doing here. All right. Feed mode. Inch per rev or units per revolution or units per minute. So something that's built into all of the generic Fanuc 4X MT drive lathe posts is string select functions that are going to select your modes based on what you've set up for options here in turning. So when we select constant surface speed or RPM, we're going to see that change reflected in the code. So if I select RPM, come on, should make me force a regen. Oh, that's right. Spindle speed you don't have to regenerate because it's just held in the binary. So if we just go and we repost this whole thing, don't worry about the errors. I was playing around in there earlier. We should be able to make this switch from G99 to G98. This is our finish sequence. Is this the right one? Oh, there it is right there. We got a G97 with an S200. So that's our RPM versus CSS. This is about the feed mode. So G98 versus G99. Sorry. So if we go inches per minute instead of inches per rev. There we go. Now we're getting the G98. So we can see that we're doing turning work here. We're doing turning. We've got some debugging going on here for coolant. So here's our lathe finish, sequence 3, sequence 4, sequence 5. So this is all lathe turning. And eventually we're going to get down there and we're going to go into milling mode. And so with milling, what you're going to see is that we've got these codes that we're going to need to activate to turn on those milling modes. And if we go in and we look at the generic Fanuc 4X mill post, a lot of those C-axis engage, for main or for sub, that stuff isn't there. So what I'm going to do, we've got this coming out as our program. And let me do this real quick. Let me reset the post. Come on. There we go. Okay, so we should be able to post this out, get no errors. That's great. So this is going to be our baseline. This is the post that Josh has already modified, and this is kind of what we're shooting for. So that's going to be our baseline. And now what I'll do is add another machine group here. And we're just going to add the regular old generic Fanuc 4XMT lathe post. So we've got that post there. And what I'm going to do is copy all of these operations. Oh, it only let me move it. I didn't want to move it. Move before. Oh, it's because I did the machine. Hold on. So I'm going to grab this toolpath group. We're going to go down to this toolpath group here. Copy after. There's that. We'll grab the cutoff pickoff. Copy it after that group. Home position must be updated. Home position must be updated. So one of the things we're getting here is this little dropped operation compatibility, letting us know that there may be issues between the two machine groups. And when we look at the details, it basically just says the home position must be updated. So this should be just fine. We'll just say okay. Let it copy those. And we'll do the same thing here. So we're going to grab those, copy after. Okay, so now we'll go back here, regenerate. Everything looks great. Now, when we copy the operations between the machine groups, we need to make sure that we go in and update the stock setup. Because you'll notice there's no stock. So if we just start to regenerate this right here, it's going to fail on us. So let's go back in and check and see what we had before. We had 3/4 inch stock, 10 inches long, sticking out 20 thousandths. Left spindle, minus 1.267. Okay. Right spindle was out at Z16 inches. So we're going to do the same thing down here for this group of operations. Say it's 0.75, 10 inches long, 20 thousandths sticking out on the Z-axis. Left spindle, we're going to say minus 1.267. Right spindle, we're going to put it out there at 16 inches. And once we do that, now that we've got some actual stock for this machine group, well, we should be able to grab that first set of operations and regenerate. Now we should be able to regenerate the pick-off cutoff and the final. So here it says tool collision with stock and right spindle. This tool is programmed to cut the stock in the left spindle, change the axis combination, and regenerate the toolpath. So we'll go back in and look at, looks like the face one generated properly. Let's just check that. Oh, I don't want to do all of them. I just want to do this one. So after we copied them, we got to go back and check all this stuff because it looks like, yeah, the axis combo got switched. So we want right upper for the axis combination. And now when we go back in the face, you'll notice that by changing the axis combination, it changed the parameters of where that toolpath was operating. And so we'll do that for all of these. We'll go back into this lathe rough. We want to make sure this axis combination is right upper. We'll do that for all of these. Lathe finish. This one's got a plane, so the mill tools don't use an axis combination. Well, they do. It's down here, but it's not really going to affect the settings because it's all derived from the plane. We'll change it anyway. We'll change it to right upper there, right upper, and regenerate those as well. Okay. Now the reason we're doing this, the reason we're creating two sets of machine groups that have the exact same operations is to be able to start with this new post and check and see what the differences are between the programs that are generated. So we're going to change the file name here. We'll just call it GenFan for generic Fanuc. Okay. Huh. Error, a valid cut type is not found. Check rotary settings. Be interesting to see which one of those is causing that. So it did generate. Here we go. There's an operation with some problems. So, besides figuring out which ones have problems, let's do this. I'm going to repost just this first set. Oh, looks like maybe those contours are giving us the problems. Yeah, G40, G41. So, let's check the lathe face. Okay, posted with no problems. We'll do the rough. Posted with no problems. Let's grab the finish, the drill, and the rough here, because those are all lathe ops. So what I'm doing is process of elimination. You know, figuring out where the problem lies. All right, so we reload. I don't get any errors there. Let's add that contour. Error, a valid cut type was not found. Check rotary settings. So what this is telling us to set or to check are the toolpath settings. And of course. Okay. And I can close that there. All right, so we'll restart Mastercam here. All right, so that's what I get for copying a machine group, doing all that stuff, and not saving. Yep, and you'll see that I've just got my first machine group back here. So, okay. Not too big a deal. What we're going to do here is, instead of worrying about copying them, we're just going to take this one machine group with all these operations, and we're going to post it, and then we're going to switch the machine and post it again. The rotary settings that it said it had a problem with are here under the rotary axis control. So we have to pick an option here. No rotation, y-axis, c-axis, axis sub for how we want to do the cutting. And based on the option that we set in the dialog, that's going to change some predefined variable values that are coming in from the NCI, and it's going to choose different routines inside the post file. So in a lot of cases, this no rotation and this y-axis setting are essentially the same. What we're talking about is we've got this contour, this mill tool, and if we backplot it, this is the motion that we're making. So if we're looking at that in the context of a lathe environment, what c-axis angle am I at? Everybody remember our discussion from last class? Minus 90. That's right. Well, it really depends on which way your axis is set to rotate, but that's either plus 90 or minus 90. If we look at this thing from the right side, and when I do that, what I really want to do here is go into stock setup and say on my display options, don't display my right stock or chuck. That way, when I look from the right hand view, I'm only looking at the main spindle. But when we talked about class, it's the back view z-axis. So in the system WCS top, it's the y-axis positive that represents C0. So if I've got a tool that's cutting from the top down, that's going to be typically positive 90. Rotation is positive counterclockwise, but you can set it inside your machine definition to be negative if that's the way your machine rotates. So what we'll do here, let's just post out this 2D contour. And if we look at just that operation, we should see that we are indeed at C 90 degrees. This is another one. Let's do this. Let's turn these toolpath displays on, and then we'll turn on only display selected toolpaths. And then we can go down here, and if we look, this contour is on the bottom. But what is bottom? Well, if we start with the back view and we rotate it to the top, and that's 90, we rotate it to the front, that's 180. So if we rotate to the bottom, we should be getting 270. So let's see if this is true. And it is. We're getting 270 degrees, or in this case, minus 90. It depends on how your machine is set up as to whether it allows signed rotation. So some machines you can get and they are, plus or minus 360. So you can actually enter a negative rotation value and it will rotate the opposite direction. Let's take this same set of toolpaths. We're going to save this. And let's just do a save as. Sample 1, gen fan. Okay, because we're going to replace this with generic Fanuc. That's probably easier than trying to add another machine definition and go through and fix all the operations, all that stuff. So we'll go back to shared MCAM-X7. Oh, and I apologize. Let me, okay, I'll open it right now. Let me get this done. So, lathe multi-axis, mill turn advanced 2-4 without the B is the machine definition that we want to use to represent a spindle, or excuse me, a machine with 2 spindles and with 4 axis combinations, but without the B axis. And that's going to use generic So I'll save that. And if we post out this contour here and this contour here, remember these are the two that we saw that were 90 and negative 90. Now we get a valid cut type is not found. Check rotary settings. So let's go look at the machine definition, and it may just be that we don't have a y-axis or it's not enabled or something. So there's our y. Here's our y. Let's go and look at the axis combinations. All the axis combinations have C, Z, X, and Y. So if we go look at our contour, see what happened. We got the left upper axis combination. We're telling it no rotation. The valid cut type was not found. Check rotary settings. So if we go back in and we pick some type of option here, either C or Y, we now have told the generic Fanuc 4X post that we want to post this out with Y-axis mode turned on. It says, I think the generic needs the rotation page set to Y. This is built off the in-house post. Yep, exactly. So for the generic Fanuc 4X empty lathe post, you have to pick a rotation type. In this case, we're taking the tool, we're moving it across the face of the part. The only way to generate that motion is either to try and do it by interpolating C or to have a machine that actually has a y-axis built into it. So we can go in and change all those. Say, yeah, I want to do y-axis. Let's see where our pocket is. Lathe finish contour. That again is going to be Y. Okay. So again, we can take this contour and this contour and we can post them. We're not getting both of those posting at once. I only see one cut. Now if we post that one all by itself, we do get the minus 90. So that's pretty interesting, right? We're getting both operations posting, but we're only getting a C0 or C90, getting a G98, G1, F25. So we're basically not getting any motion. If we go in and we change it to C-axis, we're still not getting any motion. So let's go look at your plane, see what you got set here. It's all set to top. We're not using polar, using the left upper, and we're using y-axis. So if we go in and we debug this, let's see what's going on. Okay, so in debug mode, we've got all of the machine definition stuff right there, all of the kind of preparatory variables that get set, all of the tool information. And then there is the 1001 code, which represents the tool change. So we're going to put a breakpoint on for the 1001 code, and we're going to hit play. And what will happen is it'll play all the way up to that point. And if we look, we still haven't generated any outputs. Let's go step statement. We're still calling all the parameter lines. So let's go to MSOF, which is mill starter file. Mill starter file is going to end up calling mill tool change. So we're going to go down to M tool change, and we'll set a breakpoint in there. Okay, so now we've hit our M tool change. And we can start looking for where we're going to output our codes. Here's our tool number. So here's where we're outputting the tool number, P common move B before, all that kind of stuff. And what we'll see, so let's go down to the linear motion, P-lin out. So we've got P-lin out, P-sur out, and P-rapid out. And I'll put breakpoints on each one of those. Breakpoint there. And a breakpoint there. And what we're doing with these breakpoints is looking to see what's happening when we're reading this motion. So I'll hit play, and we'll hit P rapid out, which is this point here. We can kind of step through there, and you'll notice that this has already kind of jumped ahead. We've gotten all of our startup codes. There's our coolant on. We've gotten our home position out. C90. We've turned the spindle on. So we should be ready to start cutting, basically. So we do step statement. Here is our pre-linear movement post block. You notice now it says if post type does not equal 2. So we're going to put a highlight on post type $, and we're going to do a watch. So post type, the variable post type $, indicates that we are in lathe mode or mill mode. So post type set to 1 equals milling. Post type set to 2 equals lathe. So by watching that post type variable or debugging it, we can tell what kind of cut we're about to do. So now we go into this post block. It says if post type does not equal 2, it does not equal 2, so that should be true. We should jump inside here. So I'll hit step statement, and it goes to P reset mode. So we're going to call P reset mode. It's going to set those options for us. Now it's going to check and say if y-axis equals 0 and c-axis type does not equal 3, we're going to jump inside here. So what we'll do is check the value of y-axis. We'll put a watch on that. And we could also watch c-axis type. So we'll put a watch on that. So if y-axis equals 0 and c-axis does not equal 3, this isn't going to be true because y-axis equals 1. So I'll hit step statement, and you notice that we bypass all the rest of that logic. So now we're doing mlin because we're calling this G1 move. So mlin, we're going to copy some values, and then we're going to call PMNC output. So we'll do the vector equate. Then we're going to call PMNC output. And now we're going to start doing the code that's in here. So if milCC, if that's on, we're going to call PMilCCB. We can check the value of milCC and see that it's 0. We're not doing can cycle conversion, so we should step over that line. Now we hit PCOM move B. This is the common move before. And now in PCOM move B, we're going to run P shift map XA. We're going to run PXYZC out. And we're going to run PSINC calc. So this one is going to map our absolute position. This one is going to calculate some values for X, Y, Z, and C. And then this one is going to be the start of our incremental calculations. So as we step into this, I'm just going to step through this. You can see that this is where we're getting our position, XA, then we map it into the machine. Now we call PXYZC out. So this is doing a bunch of calculations for us about calculating the C axis. So calculated our feed rates. Now we're doing the incremental calculations. Okay, so we just went through all the code in PCOM move before. Now we're doing PCAN, PIndex. So nothing in PCAN, nothing in PIndex. We do P position C axis linear. Nothing there. Now we're looking at the value of G code. So if G code equals 0, we're calling P rapid out. If it equals 1, we're calling P lin out. If it equals greater than 1 or less than 4, P sur out. So here we're going to skip over the call to P rapid because that's not true. G code does equal 1, so we're going to end up calling P lin out. And here what we're looking for is to see why we're not getting any output to our code that's kind of meaningful as far as positioning. So we call PCAN1, PBLD for block delete, and $, SG plane. feed. And so here we got a G98 from the SG feed. Exact stop is not turned on. We got our G1 cutter comp. So we move that out of the way. It made a call to SCC comp, but that variable is not set. So PWCS, PX out. And if we look at the value of X abs, you can see that it hasn't changed from the last time that we output it, which is why we're getting no motion. So we'll go and we're not getting any X output. If we call Y out, no Y. So this is why we're not getting any output, because all our variables have already been updated. Where's my Y abs? And there's nothing to output for feed, coolant, string can text. So we've got this G98, G1, F25, but at some point all of our values got updated. Now we did position to, X20, Z10, right? But we now need to see where we're actually moving. If we look, there's some y-axis motion there, even though the z and the x haven't changed. So the next hit on plin, if I just hit play, we should hit on plin again, because now we're on this next line of code. So now we should look plin 0, so if post type does not equal 2, post type does equal 1. We're going to go in and we're going to start calling all of this code. Do all the mapping. Doing all of the C-axis calculations, feed rate calculations, and all of the incremental updates. So now we get down to where we actually call plin out. And what we can see is that we've already done our calculations, okay, because we do all of the calculations in, where was the P? In this common move before, we've done all of the calculations to update all of our XYZ positions from the NCI file. That's what happens in pcom underscore move B. So it's a very important post block because it ends up calling a whole bunch of stuff. So after we've done the calculations up here, these are the output blocks. We have position C-axis linear if we're in tool plane mode, or we're going to call P rapid out, P lin out, or P circ out based on the status of G code. So we are getting linear motion. I don't know if we have G code $ watched, but we are getting linear motion. But the problem is those values aren't mapped. Okay, they haven't been updated. So we're going to have to figure out where that bug is in the generic Fanuc 4X MT Lathe Post. Now, that's going to come probably next class. One of the things I want to focus on for the rest of this class is on making sure everybody understands how to program with a C-axis. So we're going to look at doing some lathe ops, some mill ops that are cross, either along the Z-axis or using the Y-axis mode. And we're also going to look at doing some face ops, some back-facing ops on the sub spindle, and understand setting up those tool planes. So let's go back in here. Let's go to debug, remove all breakpoints, and we'll just play. Okay. So let's close that out. Okay, so this is the part that we brought in last class. Pretty standard C-axis type part. It's kind of small, which is nice. And we've placed it with its center at the origin. We revolved it. We used the create profile, turn profile command to take the part itself and do a revolution and give us the profile. When we've got a profile like this, we just generate it on the top, meaning that if we're above the X-axis center line, or if you're in lathe mode, the Z-axis center line, if you're not in the top view, that we can really only program, I shouldn't say we can only program. If we program from the top now, all of these X coordinates for our lathe are going to be positive. If we program on the bottom, it's all going to be negative. If your machine's lower turret has positive going, from the center line this way, if it's kind of backwards, that's when we need to go in and make some modifications to the post to get it to flip the sign when it's on the lower, and we can certainly look at doing that. Today, however, we're going to look at programming. We're going to look at setting up some tools and cutting on different faces of this part. So we're going to take this part and go through the process of programming it. We're going to talk a little bit about POCO as far as using POCO. We're not going to get too much into the pick-off, cut-off, post blocks today, but we will be doing that as we go through this class. So let's take a look at actually programming this thing. We've got a rough pass right here that we're using to remove some of the excess stock. Let's go back in there and let's write a face path, face it off. So here we can use that same tool. If we do have a separate finish tool that we'd rather use, of course we could switch. So if we didn't mind having the tool change, we could grab that. Now, depending on how your tool is set up, you may need to edit that tool. If this was actually tool number 2, we could go in and we can make those changes here. Tool station number generally is going to be the pocket that we're in, and it depends on if our post is set up to read that or not as to whether it actually calls out the station number. We'll just set it to 2 here. Remember that the most important thing we can do while we're in the process of setting this up is click on the Draw Tool button, because this will show us how our tool is oriented right before we're about to make the cut. So with a combination of things like the holder side, whether we're on left or right here, and the settings that are in setup tool, right? We've got top or bottom, we've got left or right spindle, we've got horizontal or vertical mounting position, and we've got our spindle rotation. So based on a combination of all these settings, right? If I just go reverse tool, and I say okay, and I do draw tool, well, that's not how I want my tool set up at all, right? That's only, you know, if I was going to be cutting with the bottom turret. So that's not going to work, and that tells me instantly, visually, that I've got something wrong. So I need to go back in here, and a lot of times these little pictures will give you a clue. Right now, our insert is facing down. So if we really wanted our insert facing up, we could, go clockwise with our spindle rotation. But if we do that, look at what we've got here. We've got a vertical tool, but it's facing to the right. In this case, if I want to switch this to face to the left, I have to click OK. I have to go back to the holders, and I have to pick the other sided holder. And now if I go back into setup tool, you'll notice that my little icon has flipped around, and it's now facing to the correct side. As always, the last thing that I have to do here is hit draw tool. I don't have to, but you always want to. You always want to, because it gives you this great visual indicator of exactly how your machine has that tool set up and is ready to cut. Got a question from Corey. Can you explain the difference between the yellow and orange inserts? Absolutely. Yellow indicates that that insert is facing up. So the body of the holder, when we're looking at this thing, is below the level of the insert. The orange insert is facing down. That's insert down direction. And you'll notice that this doesn't show the orange insert, but what it does is to flip the holder around and not show you a picture with the blue, the light blue, and the yellow, because that's indicating that our insert is facing down. When I do that, again, I have to go back into the holder, and I have to flip the side of the holder, because now it's on the left side. So you'll notice here, this is insert down. We don't show the insert, but when we finally hit draw tool, we do. And the orange simply indicates that this insert is facing down, and the bottom of the holder is now facing up. And that is controlled through a combination of which side style are we using, left or right, and the combination of settings that are for your mounting position, the active spindle, which turret you've got selected, and how that spindle is rotating. So you've got all these settings that really kind of interact with each other to determine, how this tool is set up. One of the things I want to mention is that you should almost always select your axis combination before you start editing the tool. Because right now I've got it set to the left upper. If I now go right upper and I go in and I do edit that tool, draw that tool, all right, it's still facing to the left, even though I'm telling it I want to cut on the right. So I almost always triple check myself, right? I'll go in and I'll set up my lathe tool. I'll make sure my axis combo is set. And then after I've set the axis combo, again, I'll go back in and just do edit tool, draw tool. If it doesn't look right, it won't cut right, okay? So just make sure that you're doing all of that stuff at the same time, that you go in and you check all of the settings. You need to make sure your axis combo is correct, and you need to make sure that when you hit draw tool, it looks correct for the axis combination that you've chosen. So right now, we are cutting, on the left side, which is good. We're cutting on the main spindle. It's oriented for what I want, which is, not that I would necessarily use this particular tool because of its orientation for facing, but technically I could. I've got enough clearance, on this side that it would work as long as I'm not using too much material. Would I do it all the time with a tool like that? Depends, If I got a B-axis lathe and I can rotate that a little bit, get a little more clearance, then maybe. But again, I'm just showing you guys an example of setting up this tool. So we've got our tool set up. Go to the face parameters. We tell it where we want to finish. Let's do 2 finish passes. Finish step over. Let's make the last pass 5 thou. Everything else looks good there. We'll tell it overcut. A lot of times I like to overcut by the amount of the radius. It really depends on how, keep in mind, the positions that you're telling it for X and for Z, a lot of that has to do with how you have your compensation set up. So that's another thing that I should probably mention. If we go back to the tool parameters and we go to edit tool and we go to the parameters tab, there are several different methods that we use for compensation, and it will depend on how your machine is set up. Right now, this is set for driving the theoretical intersection point of our tool radius. So all of our coordinates, the toolpath will automatically offset that radius and position it correctly on the geometry. But all of our coordinates are going to be coming out from that theoretical intersection point. Sometimes you need to use compensation that's at the center of the insert. Depends on the machine. And what you're going to be entering is the tool nose radius value, and you're going to be adjusting that tool nose radius value, and it will compensate on like a complex contour. A lot of the machines only have X and Z comp on them. So if we're doing this, intersection point compensation, you can adjust the diameter compensation versus, the compensation in Z, but you couldn't offset the radius on a 45-degree line very well, or as it goes and transitions along a complex contour. There's also centerline compensation and dual point compensation. So this will actually let you have a regular offset and a back offset value. We often use this with grooving tools. So just keep in mind that you're going to have to find out what type of comp your machine uses and adjust accordingly. So I'll let it generate that face path. So we faced it off, and now I'm going to take that tool path, or I'm going to create another tool path, and we'll just do a finish. So we're automatically in partial chain mode. I'll grab the start of my contour here, and we'll grab the end of the contour here. Oh, well, how about let's turn weight on. So reverse it. There we go. So this is going to be the cut we're going to use. Now you'll notice when I did my roughing cut, we stopped right up here on this line, so I've still got a fairly thick amount of material over here. What I probably want to do is just go ahead and generate this finished path, let it do its thing. But I'm going to go back into this roughing cut right here with my roughing tool, and we're going to extend this exit amount so that we go past and clean up a little bit of this bar. So with my roughing tool, I'm going to go back into the rough parameters, and what we're going to do is say use remaining stock for our stock recognition on the exterior of the part. When we do that, if I go in and click on adjust stock, you'll notice that we get this little orange kind of transition boundary. And one of the things that we can do in this, there's 2 different points. There's the end and then there's the start. So if I go to the end point, sometimes you can hit this little button and you can have it like auto recognize where that stock exits or where it ends. So if I do that, I'm going to try and, machine this whole thing, and that's not really what I want. So I'll just leave it on the regular end stock. And what I'm going to do is adjust my lead out parameters to extend my cut a little bit past the end of the part. So we're going to go to lead out. And we have some options here for both lead in and lead out. For lead out, I'll click on the lead out tab. And what I'm going to do is extend or shorten the end of the contour. So in this case, we'll say extend. Let me get like another 3/8 of an inch on that, back end of the contour. And so that's going to extend the contour before I do my exit vector. So you'll notice my exit vector right now, I'm exiting at 45. Depending on the shape of the insert, that may leave a little bit of an overhanging cusp. So I might want to go with a vertical exit instead. It depends on the tool path. Maybe even, if this resolution was, say, 5 degrees, maybe I want to do, come on, there. Maybe I want to do a 95-degree angle on my exit to give it just a little bit of a taper back towards the chuck, or maybe 10 degrees. There we go. Angle 100. So you can play with these settings here, and you can adjust the tool path. If you're cutting something that's scaly or something and you need to go slower, or you want to go faster because you're exiting out and your material cut is lessening as you're in the exit, maybe you want to speed it up a little bit. So anyway, I will adjust those settings and we'll regenerate that tool path. And what you can see is that now I've got this exit, and it works okay over here, I suppose, but I don't really like what it's doing right here. So let's change that to just be straight up vertical. That should work for us. So we'll go lead out, 90. Okay. I like that a little better. So now we'll go and regenerate the rest of those. You notice that my stock is still orange. If my stock boundary that's being displayed is orange, that means I have a dirty toolpath somewhere, so it's not going to update until I finish regenerating. So I'll regenerate that one. We'll do the finish. And now with the finish, I need to adjust the same thing. I need to go back into the lead in, lead out. And for the lead out, we're going to go extend. Let's extend by like a 1/4 inch and 45-degree lead out. Oh, let's go vertical. Okay. Depends on where I'm going to put my, my part off tool. As long as I'm going past my cutoff tool, retracting at 45 degrees, probably just fine. Okay. So we can probably go back in there. Let's go back into lead out. Let's extend by 0.3, but let's go 45 like that. And regen. Okay. So that looks a lot better. Now we need to start doing the bore. Okay, and I think you drilled it first on there, didn't you, Josh? And then you were using a little boring bar to clean it out. So we're going to do tool paths, lathe drill. I can't remember which tool you had. You know what we're going to do? We're going to save this. We're going to go back to Josh's original part. We're going to create a tool library. So if I go into the Lathe Tool Manager. I'm going to go create a new tool library. And we're going to copy all of the part tools into that library. And then we're just going to say OK. Should ask if I want to save it. Oh, you know what? We got a new option. Import tools from an MCX file. Let's just do that. So if we go back in here, we go Toolpaths, Lathe Tool Manager. Let's go import tools from an MCX file. Pretty sure that's the one we want. Yep. So let's go in that one. Now we're going to enter a name for our new tool library. Oh. There we go. So we'll create our new tool library. Well, that didn't work too well. Import tools from that guy. Unable to add tool list. Huh. All right, well, let's see what we got when we saved out that other one. That looks a lot better. Okay. All right, so now we need to drill. Let's see which drill we're using. Mini boring tool, mini boring tool. That's on the sub. So it looks like this is the drill you were using. We'll bring that one up here. You're also using a boring bar. Let's see. Hey, Josh, which boring bar were you using to clean out that interior there? Not sure. All right. Well, we'll get to that in a minute. So now we're going to drill it. Toolpaths. Drill. Gonna grab that guy. Parabolic drill. Oh, nice. Show library tools. Make sure we're still in left upper. So here we've got our initial drill point. Usually the face of the part. How much clearance we want. Incremental. We got a retract value, and we're going to do depth. We're going to go pick it. Right there. So we want to leave a little stock on the bottom. Let's go plus like 0.02 just to be safe. And we'll do check break. All right. So now we've drilled that out. Now we need to come in and start boring out the face up here. So we're going to need some geometry to do that. We're going to need either a line or we're going to need a line going this way. So let's do this. Let's give us both. I'm going to grab this line here. We're going to do a copy of that line along Z, and we'll say 10 thou. And we'll say OK, or apply. But now I'm going to do this one, and we're going to go maybe 0.1 at 0.09. that end up? Huh, maybe I went to 0. All right, let's do this one again. Translate 0.09. And all I'm going to do with these two lines, how about a flat bottom drill? We could certainly use a flat bottom drill on this to clean it out if we had one. But I think part of what we need to do is show boring, like ID boring here. There. And I'm just doing that to give me some geometry that I can use. I can either use this horizontal line here, or I can use this vertical line here with the boring bar to come in here and clean that out. So if we do toolpaths, finish, and we grab, say, this line, now I'm going to go in there and grab one of these little mini bore tools. $400. 060 min bore. Wow, that's a tiny one. How about 160 minimum bore? I think we've got that. So what we're going to do with this guy, finish step over. Let's go 015, number of finished passes, maybe 6. And we may have to play with the lead in and the lead out to get what we want. You know, we may want to go 10 degrees on that and adjust that a little bit. We'll have to see. Lead out coming back at a 45 degrees. That's probably okay. But 0.1, we're going to go like 0.02. Now, something to be aware of. Let's go 0.02 on there. I'm going to select OK here. Something that you need to be aware of is what your rapid distance clearances are from the stock. So I'm actually going to hit OK here, let it generate. Bam, bam, bam. Come on. It's on the wrong side. That's fine. We're going to fix all that in a minute. In your setup, under stock setup, we have some options. I'm trying to remember where they're. Oh, sorry. Tool settings. Tool clearance. You'll notice that we have rapid moves 0.03 and entry exit moves 0.01. The tool clearance values are a boundary that get applied as a profile around your tool. You can see there's this little black profile that looks like an offset from your tool. And these are the incremental clearances that we use off of the entry exit move when we're doing stock. So you'll notice on things like a roughing path where we're re-entering the stock, we're going to make sure we have a minimum of 0.015 clearance for our entry move. And our rapid move says, all right, we're going to rapid to within 0.03 of the stock. And if we get close to the chuck, we're going to stop a cut. So if I told it, hey, I wanted to cut the entire, profile of this bar, but it came within the chuck, we would hit this 0.03 and it would stop it and prevent it from hitting. One thing you need to be aware of that's especially important here is if you are working in a tight bore, these values can really hurt you because it will try to attempt to be smart and you can end up actually smacking your tool, the back side of your tool, because it's trying to give you 30 thou of clearance on the front of your tool as it's exiting the bore. Okay, so if you're working on a real tight bore with a tool that's very close to the bore diameter, a lot of times I will go in here and I will make this like 3 thou or sometimes even 3/10, you know, if I really need to get my tool in there. I forget what the minimum is. 03? Let's say, yeah. So like 3 thou here, and you may even have to do this, you know, with your, looks like 1 thou is the minimum. Okay, so you may even have to do that with your entry-exit tool clearance for your entry and exit moves. Okay, so just be aware of this one. It's one of those things where we try to help you out, and if we think that you're gonna hit something, we try to prevent that. So for those of you guys that don't like to get that close, you can also bump those values up, right? Like if you're worried about your rapid moves being close to a chuck, okay, you can have it offset that. You know, another thing that'll happen is you might have your secondary spindle close to your first spindle, and the entry move would normally kind of go right through the second spindle. This tool clearance on the rapid move will offset that entry move and kind of move the tool around that chuck boundary. So in those cases, if you haven't defined your chuck jaws accurately, you may want to bump that up to like 2 inches. You know, you may want to keep your tool way off of that chuck as it's trying to get to your start of cut and as it's trying to get from the end of cut back to the home position. Okay. We went a little bit longer for the first half of our class than we normally do. So I guess that's fine. We're going to go ahead and take our 15-minute break. We take a break in the middle of class, and part of the reason we do that is because I need to split the recording. When we record these training sessions, it takes up a lot of memory. And a lot of hardware, a lot of hard drive space, I should say. And to make it easier for us to edit and put the videos together, we split it in the middle. So what we're going to do is go ahead and take a 15-minute break. We're going to come back at 4:32-ish. Okay, give everybody a chance to get up, stretch your legs, grab water, use the bathroom, you know, whatever you need to do. So I'll save this where we're at right now, and I'll go ahead and, oh shoot, sorry, hold on one sec. Let me resize this. Okay, that way it fits in the video recording. All right, so I'm going to go ahead and